Good morning, everyone. Let's see, I should probably send out a remind message and make sure people remember to come to the YouTube channel. I'm going to wait until the number of concurrent viewers is above 30. Morning, Mo and Will. All right, just sent out a remind message. Waiting for more people to log in. Hello, Mason. Good morning. We have a observer this morning. Hazel is observing. If you're just logging in, I'm waiting for 30 concurrent viewers, and then I will get started. Mom, if you're watching, hi, Mom. My mom sometimes watches my YouTube streams because she lives in a different state. So don't say anything bad in the live chat. My mom will see it. Actually, I doubt my mom is awake at this time. Good morning, Selma. Good morning, Andrew. Still waiting on some more people to join. Hazel is observing today's lesson. I guess she's not really observing, she's sleeping. I will wait until 8:05 at the latest, and then I will start. I've got about half the class here. Good morning, Christian. Dum-de-dum-de-dum. Pretty crazy. Well, yesterday was pretty crazy, huh, with all the ash. I don't know about you guys, but I had a ton of ash on my car. Or I have a ton of ash on my car. I haven't cleaned it off yet. Still waiting for a few more people, or 8:05, whichever comes first. Did I tell you guys I'm taking Spanish 1? Taking Spanish 1 with Maestra Vieira. Got myself some children's books in Spanish. I'm excited about that. I'm going to start in 1 minute. All right, I think I'm going to start. Oh, there's a question. If I could be a Pokemon, which Pokemon would I choose to be? I think I would be my favorite So you have to keep in mind that Pokemon. Um, I played the original Pokemon like Red and Blue, um, and so I only have the original 150 Pokemon in my mind. And so I think my favorite Pokemon that I liked, what is it, Alakazam, the psychic Pokemon. What's the highest evolution of the highest Pokemon that can bend the spoons? I think it's Alakazam. Yeah. All right. So I'm going to start. First thing I wanted to talk about is I wanted to, since this is only like the second time that I will that I've actually taught to you guys instead of just going over instructions. I want to remind you to go ahead and submit the daily attendance if you haven't already. I also want to remind you that we have our first assignment is due on CodeBoard tomorrow. So that the way it works is if I assign you something during a given week, the assignment is always going to be due the Friday of the following week. So last week's work is due this Friday. This week's work is due next Friday. Okay? So remember to submit that if you haven't already. And the other thing I wanted to remind you about is that every day from 1:40 to 2:30, I will be in my Zoom room, okay? And you can ask me any questions. And when I'm in the Zoom room for office hours, I'll let you guys share your screen with me so I can see what you're programming. And yeah, so I think that was really effective. Last week, I had a couple people ask me for help. So immediately following this lesson, we will transfer over to the Zoom room, okay? Now, because this class period is actually made up out of two classes, there's SL Computer Science and there's HL Computer Science. I'm going to give sort of two lessons today, and I'm going to start off with the SL, okay? If you're in HL, I want you to stay on the YouTube live stream, but you can switch to another window, and I want you to start working on today's assignment, which is in Canvas, okay? So this lesson is going to take probably about 15 minutes for SL, and then I will talk to the HL people, okay? So I hope that makes sense. So I'm going to switch to here for a second. So what are we going to talk about with SL today? So the first thing we're going to talk about is getting input from the terminal. So how do we get input from the user, from the terminal? And there's a class that we're going to use to do that. It's called the scanner class. Okay. Now, one of the things that I want you guys to get used to doing is looking up the documentation, the Java documentation, okay? So for example, I'm going to switch to this scene. So here I have the Java documentation for the scanner class. And so here at the top it says class scanner. This is the official Java website. It's docs.oracle.com, and what it has is it has all the information about the scanner class, and in particular, it has all of the methods of the scanner class. Okay, and so I find that when I want to learn about a class, it's easiest to just go to the Java website and read about all the methods that a particular class has. Okay, so that's really a useful thing, and I find that it's a lot more condensed than you might find it in your textbook. Okay, your textbook might have an entire chapter about strings, for example, but you don't need to read all that. You just need to know, what are the methods? What can this class do? So this is really nice. All right. So let's talk about how to use the scanner. So this, I'm going to be doing the coding on CodeBoard this morning just because it was a little bit laggy last time when I was using IntelliJ while I was streaming. It was too much for my computer to handle. So first thing, if you're going to be using a scanner, you need to import the scanner. So import java.util.scanner. Okay? If you try to use the scanner without that import statement, you're going to have a compile time error. Okay? So let's say I'm writing some code that utilizes the scanner. So let's create a scanner. So scanner, my scanner equals new scanner. All right, and I have to specify where is the scanner getting input from. So it could be a file. Later on in the class, we will collect input from a file, but today we're just getting input from the terminal. So you want to type system.in. Okay. So the scanner is going to basically read the terminal. So how do we get input from the user? Okay, so there's a method of the scanner class, which is over here, and it is called the next method. So the next method gets input from the user. Okay, so I'm going to say my scanner, well, let's say string s is going to be assigned to my scanner dot next. Okay, so what this line of code is going to do is it's going to get input from the user, and it's going to assign that input to the string variable s, and then let's have the program output what the user typed in. So let's say system.out.println s. Or let's make it a little bit more complicated. Let's say you typed, and then we'll use plus. Do you guys know what happens when you use plus with a string? It's called the concatenation operator. So it's just going to tack whatever the user typed in after that sentence. Okay? So let's compile this. Compilation successful, that's right here. And I'm going to run it. Okay, so I'm running this program, and I didn't output anything to the terminal like to tell the user to do something. So I'm just going to type in blah, okay, and I'm going to hit enter, and it says you typed blah. That's exactly what we wanted the program to do. If I type blah again and hit enter, nothing happens because the program is over. Okay. Let's run it again and say, what if I type blah blah? If I type blah blah, you notice that it only says I typed blah. It doesn't say I typed blah blah. Okay, so why is that? If we look at the documentation for next, it finds and returns the next complete token. So the token is basically a word. Okay. There is a method that will get the entire line. It's called next line. So what if? So here it is right here. So what if I use the next line method instead of the next method? So I compiled it. Now I run it, and I type blah blah, and now see how it's reading the entire line and putting it into that string. So if you need a whole line, you got to use the next line method. And then there are some other next methods that you might want to know about, like next int will get an integer from the user, next double will get a double from the user, and so on. Okay, so that is the scanner class. Okay, I'm going to monitor the live stream. Cool, no questions. So the next thing I wanted to talk about is the string class. Okay, so strings, the class string, it's basically text, lines of text. Essentially, okay. One of the things that you should know about strings are that they are stored in the heap. Okay, so remember in Java we had the stack, and then we have the heap. So the stack is kind of like the to-do list of the program. The heap is where all the data is stored. And primitive types such as int, double, boolean, char, those primitive types are actually stored in the stack. The data is stored in the stack because they're so simple. Strings, on the other hand, are an object, and so the string object is stored in the heap. Okay. Another thing about strings is that they are immutable. So mute, that means like mutation. Okay. Immutable means you cannot mutate it. You cannot change a string once it's been created. Okay. So it can only be, you know, if you have a string variable s and you assign it to a new value, you're actually creating a second string. You're not changing the value of the string that was already there. Okay, so all you can do with strings is create new ones. You can never modify an existing string. Okay, so let's see how that works. So let me go to here. So string, okay, so let's say I have a string s, and let's say it's equal to hello. All right. And let's say I assign s equal to goodbye. So what's going to happen here is we actually have two strings in the heap. There's a hello string and there's a goodbye string. So what happens when I do this reassignment in line 7, I do not erase the hello string and then create a goodbye string. I still have the hello string in the heap, okay? So that's an important thing. I'm going to do a little test of strings and see if you guys understand them. What if I say string s equals new string hello. Okay, and what if I say string t equals new string hello? Okay, and then I say system.out.println s equals equal to t. So what do we think that that's going to print? All right, I'll give you a second to think about it. So the answer is either going to be true or false, right? Because this is a comparison operator. And these two strings both say hello. So you might think that this is going to return true. But let's see, it actually is going to return false. So let me run it. Look at that. It returns false. So why does it return false? Well, to understand that, I'm going to go to the document cam. So when you created that first string that was called hello, here's the heap. You create a string called hello in the heap, okay? And then in the stack over here, you have the memory address of the string s, and it points there, okay? Then when I created the string t, notice how I said make a new string called hello. So what that tells the compiler to do is it says make another space in the heap and put a string in there that's called hello. Okay, and then in the stack we have the memory address of those. So what does the comparison operator do? What it does is it compares what is in the memory addresses. So basically what this is doing is it's comparing the memory addresses of two different strings. Two different strings that say the same thing, but they're at two different locations in memory, and so that's why it gives false. So what do we do if we want to compare the content of two strings? There's a special method. So right here I have the string documentation, and if you want to compare strings, in general, if you want to compare objects, not primitive types, you would use the equals method, okay? So there's a number of really useful methods for strings. But if you want to compare the content of strings, you would use the equals method. And so let's see how that would work. So if I want to know, does s equal t in terms of content, then I would say equals s dot equals t. Okay, compile that, and then let's run it. And this returns true, because this is not comparing the memory addresses of the strings, it's comparing the actual content of the strings. So the lesson of this is you only use the comparison operator if the two things are primitive types, not objects. You use the equals method if you want to compare objects. All right. So the third thing that I want to discuss for my SL computer science students is one of the control structures that we didn't get to on Thursday, which is called the switch statement. And the switch statement basically allows us to choose between options. Okay, and so the syntax for a switch statement is we're going to say switch, and then in parentheses we're going to have some variable. that can take on a bunch of different values, okay? And what we do is we say case A, case B. So these are all the different values that the variable can take. And then we have some code. And then we might have, like, say, a case default, etc. So let's see how that works. So I'm going to write some computer code. I like the switch statement. It's a nice, it's pretty useful. So let me show you how I like to use the switch statement. So let's say I have a scanner, my scanner equals new scanner system.in, and then I have a string input, and I'm going to initialize that string to the empty string. So the string input does not have anything in it. Okay. And then I'm going to use a while loop, and I'm going to say while the input is not equal to exit. Okay, so while the input is not equal to exit, I'm going to do some stuff. Okay, and the stuff that I'm going to do is a switch statement. All right, so let's type in some code here. So first of all, we're going to let input change to what the user types in. So input equals my scanner dot next. So input is going to be assigned to whatever the user types in. And then I'm going to say switch on the input. Okay. So depending on what the user types in, we're going to do some different stuff. All right. So first of all, I'm going to say case 1. So what if the user types in 1? Then we're just going to say system.out.println you typed 1. Okay. And then we always have to say break after the after that particular case. Then we say case 2 system.out.println you typed 2. Break. And then so you could have as many cases as you want to handle, okay? Remember, at the end of each section, you have to include break, though. One thing that's useful is you have a default statement, which is what happens if none of the cases that you have defined occurred. So that's called the default case. And we'll just say system.out.println you didn't type 1 or 2. All right, pretty basic. And so if we look at this code, because it's in a while loop, it's just going to keep going and going. It's going to repeat this block of code. So it's gonna get input from the user and tell them what they did repeatedly until the user types exit. So this has a very like menu feel to it. Okay, so it's just gonna keep doing something until you quit. So let's try this out. So I'm compiling that, compilation successful. Let's run. Now, if I was writing, a more complete program, I would prompt the user to do something in the terminal. But let's just say I type in 2. It says you typed 2. All right. Let's say I type in 7. You didn't type 1 or 2 because that would fall under the default case. And notice how this just keeps going, okay? So maybe I type 1 now. It says you typed 1. Now what if I type in 2 again? The while loop is still going, okay? So this using the while loop allows the program to just keep running until I give it the keyword that would allow it to exit, which is the exit token. So what if I type in exit? It says I didn't type 1 or 2, but it exited that loop, which then completes the program, okay? So what if I type something in after this? What if I type that? See how nothing happens because the program has quit. Maybe I should include a case like what happens if the user types exit. Maybe I say system.out.println goodbye, something like that, and then break. What happens if you don't include the break statements? If you don't include the break statements, then everything after that case is going to run. So for example, if I deleted all these break statements, then what's going to happen if I type in 2 is it's going to say you type 2, but then it's not going to break to the end of the switch. It's going to also type goodbye. And then it's also going to type, you didn't type 1 or 2. Let's try that. So what if I type in 2? See how it handled the 2 case, but because I didn't say break, it's going to also do the exit case and the default case because those are below it. Okay, so you got to be careful about including the break statement. All right. So that is the SL lesson. So if you are in SL, I want you to remain in this live stream, but I want you to go ahead and start working on the daily assignment. And if you are in HL, I just have a really quick lesson for you guys on recursion. So if you are in HL, go ahead and switch over to this screen. And so we're going to talk about recursion. Wahlberg's in the house. All right. So recursion is basically you have a method that calls itself. A method that calls itself. That's recursion. So let me give you an example. What if I wanted to write a power function? Okay, so what if I have, public int power function. Oh, Wahlberg is waiting to enroll in classes. I remember that. So the power function, and it's going to take an int base and an int exponent. All right. So there's our code for power. And this is going to be really simple. So this is basically going to compute base to the exponent. All right. Base to the exponent. So how do we do that? Well, we're going to use the fact that this is equal to base times base to the exponent minus 1. Okay, that's just a fundamental property of math. So what I'm going to do is I'm just going to say return base times power to the using the same base, but with the exponent -1. So that's a recursive method to compute power. Okay, so this is really simple. And another way you could do it is with a for loop. You could say for, I equals 1 to exponent multiply. So what is the advantage of recursion? Basically, the advantage of recursion is it simplifies the code. Or I should say it can simplify your code. It can give you really elegant solutions to problems, and I'll show you an example of that in a second. All right. So that's the advantage. The disadvantage is that it can be really inefficient. It can be really inefficient, okay? Because, for example, what if I tried to calculate, I don't know, 0.99 to the 1 million power, okay? Something like that. How many calls of the power function am I going to get? I'm going to get 1 million calls of the power function, right? For each time I do that. So that's going to take up a huge amount of memory because in the stack you are including, remember that the stack is your program's to-do list, and so it's going to have 1 million copies of the power method, and that's going to take up a ton of memory in the stack, and you have a risk of creating a what's called stack overflow, where you have too many items in your to-do list. Okay, so that's a huge disadvantage of recursion. Okay, is it can really use up a lot of memory. You can have sort of like exponential growth of the number of calls of the method. So actually, a much better way to do this would be to sort of like if instead of doing this, we said, what if we returned power of base and exponent over 2, and then we just squared it, okay? So we kind of do this squared. I'm writing pseudocode here. So why is that better? Well, that's because this is basically going to call the power function a fewer number of times, okay? Because we're dividing by 2 each time, so the number gets exponentially smaller, okay? One of the things that I forgot to include here is you always have to have a base case, which is, notice how we're reducing the exponent. So eventually the exponent is going to become 1 or 0. So you have to tell the method what to do in that case. All right. So I want to show you kind of a cool application of recursion, which is this game. It's called the Tower of... You know what? I'm going to tell you about the Tower of Hanoi tomorrow, or on Monday, because we're 40 minutes into the lesson. So here's what we're going to do. We are going to head over to the Zoom room. All right? So everybody in the YouTube live, let's go over to the Zoom room at this time. Okay, see you.